Тема моего сегодняшнего доклада называется «One
Hello,
policy to
everyone.
rule them all» или «Одна
One policy to rule them all. One policy to rule them all.
Ivanov Gleb. Я
I'm
являюсь
Gleb Ivanov. I'm the head of the targeted attack research team lead. You may remember me with the previous PhD conferences. I worked in the research SOC team. I was a SOC analyst. So you may have seen me already somewhere. So what's this presentation going to be about? Group policies, that's what we're going to talk about. What's it like? How the attackers can exploit us. And we'll speak about group policies, attacks examples. I'm going to give you a few examples on how we're going to monitor the targeted attack vector. We're going to show you the monitoring logic. We'll be adding this to our services. So let's speak about the theory. What's group policy? The GPO is made up of two things: group policy container and group policy template. Group policy container looks like a held-up. You can find it in held-up base with its attributes. Next important thing is group policy template. Group policy templates indicates the real path where GPOs sit, because it shows the domain share, syswall, and you will find a folder of sys policies. In this policies folder, you will see the GUIs of different policies, and they will contain the actual settings that are used for the clients. One of the group policy containers things is the syspass file. The GP file syspass indicates the place where you will find the group policies. The client considers the held up attribute and sees the path where you will have to find these policies to apply the host. The next thing, the most important attributes that you can find it in group policy containers is GPC machine extension names and GPC usernames. Machine extension names applied to policies for hosts, and user extension names are for users' policy. What's all like? The attributes can present client-side extension names, CSEs that explain the customer what exactly the client should do after GPO is applied, and they will have CSEs there, client-side extensions, which specific activities they need to do for that. So as far as CSE is concerned, client-side extension names are modular components on Windows. You can see it in each branch of the registry and the host, and it looks like it's the name of the DLL that will also be uploaded there. For example, with the GPO, you decided to roll out some scripts, you would like to roll out some settings in the registry so that the client understands what exactly he needs to do. So first of all, he goes to the registry, finds a CSE, and in this CSE they look for the things that they need to apply. CSE is the group policy reference component. There may be different ones, different CSEs, and the CSEs are taken from the registry with the DC. That's how we find all of the necessary information about client-side extension names. The next thing which is important is a GP link. The GP link actually connects our GPO with the organizational units. So we have a GPO which is specifically applied to specific service names, or we have the GPO which is applicable to certain machines, like, for instance, a web service or something like that. So there will be some specific settings available, and you will be able to see it in our GP link. What does it link to? These organization units will be fixed there. So what does how client works with it? First of all, they look for DC. They find it with the DNS server. After they find DC, it uses held up to connect to it. Then it comes up with a SOM, scope of management. Scope of management query contains units, users, so everything which this client hosts. So, for example, the client is a web service and it says to DC, I belong to this and that group. On my host, I have such and such users logged in, so I need to get those GPOs to download. It downloads GPOs and it stores them in cache. It stores them in system 32 cache group policy folder. And then it does all these things and analyzes machine extension names, user extension names, if the GPOs are scattered on a machine, on a user. So they check what exactly they need to do and goes back to sysvol if needed, loads the configuration, and then they execute. How do attackers exploit it? How it can be exploited, and what hackers can do using GPOs? Like it was said previously, many attackers very often use GPOs to roll out something malicious, because it's a centralized mechanism to very quickly seize the entire domain, Active Directory. What can an attacker do? So I will tell you that everything is limited with the fantasy of the attacker. We can add scheduled tasks, admins, it's one of the popular ways. You can change the path, deploy an evil MSI, deploy a new evil shortcut, and everything will be applied to a client, and such things go unnoticed, because if we don't monitor actively the client's actions, we will not see all of these things, especially if we check all of the branches of the registry. It becomes very complicated. So thus the attacker is limited to only with his fantasy. By grabbing GPO, they can grab everything. So what are the main files and folders in GPO? They store it in sysvol folder. One of the main files is gpt.ini. It contains the main GPO configuration file. It contains the GPO version and status. Clients check that the file determines whether the GPO has been changed and should be reapplied. So the older version needs to be replaced with a new one. The next file is registry.pol, is a binary file storing registry-based policy settings. It's created by group policy administrative templates, which is a tool that attackers can use to get settings to the registry. They may shut down protection softwares, launches. They can launch random settings in the registry. If you've seen it, if you have ever seen it in GPO, for example, they shut down Microsoft Defender on all of the devices, etc. That's what they do through registry.pol. Then it's followed by gpt-template.inf. It contains security policies and settings, like, for example, audit policies, where we have the account policies, rights assignments, followed by scripts.ini. Scripts.ini, it shows us the path to the folder where such scripts are kept, and it points out the scripts that can be applied to the client. Then there are plenty of XMLs planned on the client and the tasks that will be conducted. Then registry.xml registry settings, which were created with the group policy preferences. With group policy preferences, they can do random settings of any random registry branch, create something active, etc. Followed by machine user. Machine is a folder which stores GPO settings which are required for different hosts. User folder indicates the folder where settings are used for users, and the scripts folder keeps PowerShell scripts, etc. So what's the actual attack? How does attack work and what it looks like? For example, Martin is in a group of IT users. It also belongs to some other group. So when there is just Martin compromised, if we have Martin compromised, we can get access to the entire domain. The attacker should just have the right DECL rights on GPC, GPO of any domain, and then all the units that are linked with this GPO will be abused. The most popular tools are shown here on the slide. The most popular tools are here. First of all, MMC with powerful functions, very legitimate functions, followed by the tool with the sharp GPO abuse, an obsolete version here. PY GPO abuse. For example, if you like Python, use it here. Use it. GPO-DT was issued in 2023, and PowerView, which contains a few settings on exploitation of the deploys of scheduled tasks, the addition of admin rights, etc. What does the attack look like step by step? For example, I launched the sharp GPO abuse tool, which you can't see in the background, but I'm doing this as a user task. Wherever this user is located, we will have this GPO deployed. It doesn't really matter whether the user uses their client machine or they use a domain or server. Wherever this user belongs, the GPO will be deployed and launched. So we create a scheduled task.xml and group policy templates. What we do next? We add a new version of the GPT.ini file. We replace it for a bigger one. We replace the GPC user extension names to the one so that the customer understands which actions the user should conduct. Like, for example, adding tasks to the scheduler. So we add new CSE templates, which the customer will do. The client will also be using GPT and taking up a scheduled task XML file. After that, we change the version number. The version number is the group policy container, which is held up. It should be the same size of the GPT.ini group folder template. After that, we can see that 5136 event has a few CSEs added, and we changed the version of the attribute to a higher one. But what does the actual client do? The client, first of all, does the query for DC. So that's what I mentioned previously. Then they see the they check version of the cached policy of the GPO. If it's a lower version than the one that has already been tuned up for group policy templates, they will apply the higher version. So they checked it out and they make sure that the GPO version is a new one. They saw it and held up and they saw that this version is a new one. Then they save the task, save new task to user cache, and depending on the setting, depending on when this particular task will be applied in the planner, it will be run. So here on the DC host,
была запущена команда cmd
cmd who am I old command was launched and it was all written in the text file. How do we monitor and detect such activities? Sharp, GPO abuse, and power view modules
некоторым функционалом.
with some functions. Each
из опций применения
of the options that use this utility has a set of CSEs that are available and ready. So we need to see these CSEs added to extension names. So let's just check out what it looks like. Here you can see this sigma on adding the tasks to the planner. So I've added the task to the planner with this Bob user. We have this in GPC user extension names. If we had a task prepared for the machine, for the host, then it would have been added to the GPC machine extension names. Followed by another example, that's when we add specific privileges for the user. For instance, here we add the debugging privileges to the user. We also use the number of CSEs for it. Also, we add an auto-launch features here, startup launch, group policy events 5136, event 5136. What's the little problem here? It seems like that these events may be legitimate, and it depends on the and it depends how frequently these rules will be run. If you use the same GPO to add new scheduled tasks and add privileges and scripts, CSE will not be stuck there. You will constantly have a huge group of CSEs added there. Thus, if you have decided to monitor these activities, I'm telling you about it. Sometimes the attacker faces a problem. They sees a user, and this user has got non-valid rights, so they can write some information to the group policy container, but the group policy templates cannot be used for using it. So there are two options of how the attacker will act. First of all, they wait for domain admin, they log in on the host, and then there is this alert message. Some of the user has the breached rights and they cannot use the GPT to write. So please yes or press or click OK to give the rights to these users. Maybe some of the admins may guess that there's something suspicious. There is no difference between these rights, and then they will start the investigation. It will be the indicator. If you've seen it closely, when the change of the attributes of the syspass file, the attacker may point out a random share where we will have group policy templates kept. So the attacker shows the win share, the accessible share in the domain, and creates a fake syswall where the settings will be stored for a GPO. But that's not all. If the attacker does it properly, they may have the GPODT tool. GPODT is a tool which shares it on the attacker's host. The shared folder will be accessible, and the attribute is changed to this shared folder. So they may relate various clients, and they may see what exactly this host is, what kind of users have been tracked and visited them, and they would use their boot hashes to continue the attack. So some people would ask a question, would that be fine? Would be fine, so that we can keep group policy templates outside of your domain? Same question was asked by a researcher called Mark Gamachi when he was still working for Microsoft. And in Microsoft they said it's not a bug and no fix is needed. Why was that done? Nobody ever explained this to him. But let's just read the official documentation from Microsoft, and it says a GPO is a virtual object that can be put somewhere outside the domain, outside of DC, which raises a few questions, but it bypasses some of the Windows mechanisms. It's funny, why do you keep this function if it bypasses some of your Windows mechanisms? It looks strange. Okay, anyway, how do we detect this threat? First of all, we need to understand what these legitimate changes of the attributes of the syspath files look like. When creating a new GPO, this attribute will also be changing. 5136 event cannot be used here for reference easily, but the legitimate path is called domain. It looks like domain, that's the path, syswall, domain policies, and then GPO GUID. Knowing this filter, we can create a sigma, and this is the sigma. Sigma is actually looking for any changes of the attribute, changing the syspath attribute, where we fix the legitimate path to the attribute. As far as you can see, these events depicted here show the win share with the fake syswall and the IP of the attacker. Right now, let's just find out some information about attacks we found in the wild nature. We found them in the telemetry, and not just with the use of our services. It was done by the MDR monitoring team. The first example is how the registry settings are changed. So what actually happens? By default, the customers ask for GPO if they are not controllers of the domain. They do it as frequently as every 90 minutes with a certain jitter. A little bit earlier, a little bit later, but still every 90 minutes. And knowing all that, they change the value. They change the value to GPO request made much more frequently, every 2 to 4 minutes. Every 2 to 4 minutes. So every client would ask for new GPOs every 2 minutes. It's done for that simple purpose that the clients will be infected with a malware more quickly and will be encrypted more quickly, so no urgent attempts can be taken to prevent that. Some protection mechanisms can be initiated, however. Here the Windows Defender was shut down as we conducted the research of one of the incidents, followed by the deployment of the actual ransomware. And right here on the left you can see that the hacker created a scheduled task called copy, and in this copy they use PowerShell to copy a file with SMB share ds.exe, and they put it in the open directory, CM program data. The next scheduled task is called start. The start shows the CMD, and CMD contacts the net logon share, and they try to launch this ransomware with the appropriate parameters. It addresses net logon if the file was not loaded on our host, but if the file was loaded on our host, the same thing happens, but they just run the file from the folder called program data. And that's not all. During the course of the research of one of the incidents in the MDR, we saw the following interesting case. Exactly at midnight on the client, we saw that the BitLocker deployment occurred. Some of the hosts, the disks of our client had been encrypted. The attacker used the BitLocker, and the attacker removed shadow copies as well in order to complicate the restoration of the system. The client was being monitored, and so we singled out the key, the encryption key for the disks, and so we told the customer, don't worry, you'll be able to decrypt it by using that same encryption key that had been used previously. But if the client doesn't have any monitoring tools, what is the attacker doing? The attacker is clearing all possible logs, so they don't have a chance to restore the disks after the BitLocker is initiated. And they remove all of the logs with a default system operation, and security logs are initiated. And after they hide the GPO usage, removing the GPOs. Removing the GPO, they delete the GPOs that had already been deployed. So we have this command, and it could not really pull out any artifacts, and it couldn't track down any artifacts that were used in the course of the attack. How can we detect and monitor this activity? 5141 event should be monitored, and we need to monitor it. If you see more than 5 deletions during the course of 10 to 20 minutes, if you see more of such attempts to delete things, obviously there is some suspicious activity going on. How to detect and monitor this activity? I repeat, if everything leads to the changes of the group policy container, or if it runs on the client. We asked ourselves this question. So if it runs on a client, seems like it's too late. But the things that we represented 5136 event is not sufficient. So what are we supposed to do? During the compromised assessment, we use a nice tool as grouper, and the grouper can actually show us the scheduled tasks created, and it shows us new privileges added and the new scripts deployed in our domain with such and such GPOs. The grouper can also show that some GPO may be vulnerable. So here, with the use of the command line, we see a user has been added, and we can see their password written in simple text. It's open password, and it can highlight this password. Another tool that has become public recently, it's called GPO Hound. It combines the functionality of the grouper and the sharp counter, and it takes those links from sharp counter of the users that have rights to change and delete the GPOs, and thus the hacker can see which exact user should be attacked in the first place. And we can see there is another utility called grouper doing it. Also, to find something abnormal, we use the following PowerShell script to find what would be the unnecessary group policy path to GPT should be pointed out in different GPOs. So in this particular case, we filter things that are legitimate and filter those that are not standard. Here we understand that for monitoring the GPO activity, we need to check our domain and see the actual path, GPT path. We can find this, but how do we actually make the grouper come up there so that we will have a trigger. We'll have a trigger so that we need to go to DC and take the actual GPO settings. Right here, we started thinking about monitoring. Originally, we started looking at 5136 event, but why would that be the wrong approach? If NSP SOC, when we have clients, when we try to talk them into extended audit, not all of the clients actually use this extended audit for various reasons, because this event can either occur at the domain, and thus create a significant load on the system, and also for other different reasons. We don't have too much. We don't have enough information in the original event in the original event. The detections were only just the deployment of CSEs and the change of the event number. With the CSE's deployment, we won't be able to understand what was bad added to the GPOs and which particular GPO was infected, so to speak. Also, this risk, there is risk of delayed order of events, delayed receipt of events. It could not log in, something like that, and due to that delay, we wouldn't have it at our disposal. And sometimes it triggers at all times if there is domain replication going on. So this event is not suitable for us with multiple triggers during replication. So we decided to take a look at the held up database change and change of the version number attribute. The version number attribute change tells us that there has been something added. There's been something added to our GPO, and thus it can be a trigger to look for files that already belong to group policy templates. The first thing we monitored is traffic monitoring. If this held up is not encrypted, which is an important remark, if it's not encrypted, we can easily track the changes and additions of the new attributes. Thus, we can easily replace multiple events. But if we have an encrypted traffic, the subtleties follow. Held-up monitoring becomes much more costly because the held-up monitoring should be decrypted, stored somewhere, etc. The next thing that we ended up with are the held-up monitor patchdog, not patchdog, but watchdog, LDAP, LDAP monitoring watchdog, and the LDAP monitor. After a while, they look for an entire held-up database, and with the diff, they track down what's been added.
данное событие не подошло тем, что
This event was not suitable for us because we don't understand where we are supposed to store this entire footprint of the base. So very often they address DC,
хорошо,
which is not a very good thing. And
хотелось какой-то более
in actual fact, we would like to have a more flexible setting. We wouldn't want to take a look at the entire held up. We would like to see the changes in certain entities. So what did we result in? Microsoft told us, so there is a mechanism like acquiring authentication from the held-up change with the use of the dissync code. This code was written by Microsoft. So you can take the base, filter all of the entities that we see, and also we checked the object class group policies, and we'd get a callback and the data from callback. This callback is a trigger for us to contact GPC and see the changes that actually occurred. Also on this slide you'll be able to see the code from Microsoft. That's how we get the changes in the database of held up. The code is using this ++ and is easily added to the system protection. So what did we do? In the VSOC research we developed our own carp-based POC. So what did we add there? On the slide you can see that I added a user to the domain, and we can see the output depending on which user added to the domain. What would be the groups for this particular user, where this user was added? Thus we can monitor not just the GPO, we can monitor any changes in the held-up base. And any other changes actually lead to the held-up base changes, which should be monitored. And with the GPO, we check the change of the version number. That's what we monitor, and we see such attributes changed. We see it in this particular code execution. So how did we do the monitoring? On this slide you can see that there was this cycle, monitoring cycle. We check the object class policies. We wait for the changes to occur in the held-up base, in particular the GPO version number attributes. If the attribute changed, we can see that we can have the policy changes requests, and we have a GPO called firewall, uses a certain path on a syswall, and it was changed, this GPO was changed, and the task was added to the scheduler, and we can see what exactly has been added to the scheduler, task manager. We can see that we did that once every hour, once in an hour, but the attackers can actually refresh GPO and make it much more frequent, like every 2 and 4 minutes. So the clients would address the GPO more frequently, and we won't see the changes there. We'll be able to put our finger on it. So one of the subtleties here to mention when you monitor GPOs is getting authentication, which would definitely be a trigger to look for which GPOs we deal with. So right now I would like to move to the conclusions. Like I said, GPOs are a strategic target of the attackers because with the use of GPO, like I said, they can do absolutely everything. Very often the GPO attacks occur very quietly because they don't have any precise mechanism from Windows. So what exact attributes need to be added or were added in the group policy. So, what are the recommendations to single out? First of all, check their rights for GPO abuse. If we have the rights delegated, it's the simplest pattern to recognize when we see the attack starts, GPO-related attack starts. If you have such users, please single these users out from the pool into a separate group. Watch them, maybe they have a specific account for them, so that it would just use the jump off to log in, etc. Also, distinguish access rights to GPOs and links, GP links. These would be the units to which the attack would spread. Admin domains, DCs, and much more vulnerable hosts, followed by regular reviews of GPOs. I already mentioned that. Grouper GPO Hound may actually show you what exactly your GPOs contain. Maybe your GPOs contain some insecure settings. And any footpathsec would go to syswall in your domain. There are no specific rights required to monitor the existing GPOs. And the main thing, that's the reason why we've gathered here, please implement GPO monitoring. GPO monitoring is the most important thing. Like we said, the attacks are very frequent. They are hidden, clandestine, and don't forget about the response. With a certain response, we can create a task to remove and delete and shut it down if SOC had detected the GPO before it ran on a client. A response can be made so that the clients would be much more secure. I'm done. Thank you very much for listening. And I thank you all for your attention and be happy to take your questions. Of course, I have an award for the best question. Command line of Linux. So the one who will ask the best question will get this as a prize. Thank you. Two questions. Quick question. What would you recommend to research the screenshot? Privileges, member of, where was it made from? So what do we start with? What would be our next step? Can we find your sigmas in the open access so that we change it? Of course, the code was represented on the slide. Also, we have here the developer of this code with whom we actually developed this concept to monitor GPO. If you need him, he may give you all of the links to the code. But also I showed some links on the slide, and you'll be able to see it later on and add this to your monitoring. Of course, you will have to use the events like event 5136 and any held up changes. You can take our code and check all of the database of held up. What do you use to map the held up links? LDAP links. We use Fooksharp-Hounder, if I pronounce it correctly. It shows which ACEs belong to each and every user. Thank you. Thank you for your presentation. And I'm here, and here's my question. Look, you told us a lot about how the attack goes on and how to monitor, and you didn't mention much about how we protect against it. Is there the extension of the group policies, AGPM? If we introduce a GPM and if we tune it up properly, it minimizes. And does it really minimize and protect us versus these attacks? I can't actually tell you anything about it because I did not check this information regarding this particular tool that you mentioned. Because there in that tool, the GPO management always about aligning it, changes. So in actual fact, it's a Git for Microsoft. The changes of the rights management of GPOs is nice for IT admins, but if we take SOC as a service, SOC, it will absolutely not do anything here, because some of our clients do some basic recommendations for extended audit, for additional settings. So the best thing here would be bringing your tools, launching this, and there would be no additional settings required. Another follow-up question. If we change the SMB share to some other one, but what if we forbid the customer to check any share where authentication is required, like Kerberos, for instance? Then they would not leave the perimeter. It's a good way of protecting the GPOs, which I forgot to mention. But also, if we address the GPOs should be on the domain, on the syswall. If there is something outside the domain, we can forbid it. And you were quite right by pointing that out.
Добрый день. Меня зовут Дмитрий. Вопрос.
Hello, my name is Dmitry. Here's my question. Extended audit policies. In our internal network, we have extended audit policies that are linked to the organization unit. They're linked to the end machines. The machines, the computers, and the servers, they are not applied there to the end devices. Have you seen it in your practice, and how do you monitor this if this happens? Take a look at the GPOs if they are applied to the working stations, but not users. It will run on the host with the system rights. It will run with the system rights, not the user rights. And it take the host and check the host and monitor the concept, using the concept that I mentioned. Look for the changes occurring, looking for the group policy templates changes, and see what exactly is going to happen in this organization unit. Thank you. May I continue? Yes. Recently, we saw a similar thing when we have these extended policies would not run and would not apply because they were tuned up in the separate depot, not in the depot, but in the standalone ones, one for workstations, another one for the entire domain, and those policies were not applied. So we read about it, and we saw an article on TechNet where there was this simple comment. We just move it to default and it will run. We put it in the default policies and it started running, it started working. And then we saw another thing. At syswall, the template folder should keep a CSV file. If this file is damaged and we cannot read it, GPO's extended policies will not be applied. It's surprising. It's amazing. It's another amazing thing from Windows.
Добрый день.
Hello.
Если используется LDAP-S.
Could you please tell us if you use LDAP-S? Before LDAP-S, before the LDAP server, we have proxy LDAP cell before that. How do we get the body of the query? The body of the query in the utility that I showed gate changes. No. If we have any LDAP query, where do we
чтобы было безопаснее.
Identify the encrypted data to make it safe. If we send it from a proxy,
Потому что мы как раз глянув на
I don't know, because
поняли, что если
analyzing the traffic, we understand that if we have LDAP-S, it gets difficult, and we decided not to go any further. We decided to look for other mechanisms
мониторинга.
Мониторинг на лету идет, да?
Да.
to do on-the-go monitoring, so you monitor it on the fly. Yes.
Привет. Спасибо.
Hi there. Thank you very much for your interesting presentation.
Очень
A few words about monitoring. It's a great tool, great tools, but GPOs are changed very frequently. So maybe you have thought about the automation of this process. Use it with the ticket system, some other systems. So how can we automate the reaction to the alerts, to the changes of the GPO? It's an excellent question. It's the thing about which we thought later. Just by simply looking at someone changing GPOs is one thing, but to interfere with that, to interfere with the attack is another story. We also thought about that. So in the future, we hope that we'll make a certain approval mechanism. This approval mechanism, and I'm talking about it as a concept, as an idea. This approval mechanism will go to SOC or sysadmin, and they will say and then decide whether this change is really required and whether it should be approved or it should be rejected. That's how we can influence the attack. Yes, GPO changes very frequently. We therefore can check and verify which GPOs have been changed and modified. If this is a organization Unity default GPO or this GPO is actually a default one, it will run on all hosts. So you need to track what exactly will be changed there. We have thought about it, and we've still been thinking about it so far, but we don't know how we're going to deploy it. But it's a great idea. It's an interesting idea. Thank you.